2016 Leaving Cert Higher Level Paper 1 question 1 is complex numbers. -4 plus 3i is one root of the equation az squared plus bz plus c, where a, b and c are an element of real numbers. It's very important. Write the other root. So when a, b and c are elements of real numbers, we can apply the conjugate root theorem, where the other root is -4 and we just change the sign of the complex part. So this is the other root. So easy marks, tiny bit of knowledge gives you marks when you know these things. So the conjugate roots theorem. Make sure you know it. Part 2, or part B, use the Moivre's theorem to express 1 plus I to the power of 8 in its simplest form. I think the best anytime we get these questions, just do a little sketch. Positive 1 plus I is in here. So just sketch your complex number. We have a 1 and a 1. So in this case, we're looking for theta and we're looking for the modulus. Now we can see the modulus is √2. So our complex number, if we can get the angle, is written in the form, or by the cos of theta plus I times the sine of theta. Now that is in the formula booklet, but if you practice complex numbers, you should never need this. So you should see that the angle is 45 because the tan of theta is equal to 1 over 1, which is 45 degrees. The inverse tan of 1, if you're not sure, in polar form, pi over 4. So we'll always write our complex number in polar form. So √2 by the cos of theta plus I sine theta. That's the complex number 1 plus I. So 1 plus I to the power of 8, sorry, the cos of pi over 4 and the sine of pi over 4. So applying this power of 8, it raises the modulus. Thinking 8 and writing 8, should be writing 2 to the power of 8, and it goes in front of the angle. So the cos of 8 times pi over 4 plus I sine 8 times pi over 4. Now 45 degrees by 8, 320, and 40 is 360. So we can use the unit circle here. √2 to the power of 8 is √2 to the power of a half to the power of 8, which is √2 to the power of 4, which is 16. And the unit circle will give us the points. So 360, we've come all the way back around to this point here, and that's the point 1, 0. So the cos of the angle is 1, sine of the angle is 0. So we're going to get the cos, if you want to write the cos of 360 or the cos of 2 pi, either one is fine. Plus, that's a plus I sine 360. We're going to get 16 times 1 plus 0i, which is just equal to 16. Part C, 1 plus I is a root of the equation z squared. And you can see a is real here, we have a 1, but b is not real, so we can't use the conjugate roots theorem. Plus 3 minus I, and find the other root in the form n plus ni. So a little bit of knowledge again can make this an easy question. These equations are all written in z squared minus z times the sum of the roots, as quadratics are, plus the product of the roots, equals 0. Now we have a plus z actually here in this one, so we have z times minus 2 plus I. So if I can get minus z, I can get what the sum of the roots are. So minus z would be times, without changing this value, will be 2 minus I. So 2 minus I has to be the sum of the roots. So if I add the roots together, I get 2 minus I. And I have they give us one of the roots, 1 plus I. So 1 plus I times something is equal to 2 minus I. So I have to add 1 to 1 to get 2. And I have to take away 2i to get minus I. And that's my answer, 1 minus 2i. We don't have to do this, but if you multiply these two roots, 1 plus I by 1 minus 2i, we should get the product of the roots, which is this bit at the end. So we get 1 minus 2i plus I minus 2i squared. So that's 1, that's plus 2. And these two give me minus I, so we get 3 minus I. So when the product and the sum of the roots are complex, we can't use this conjugate root theorem that we had at the start. So this is when if you multiply minus 4 plus 3i by minus 4 minus 3i, it's like the difference of two squares, and the answer to this will be minus 4 by minus 4 is 16, minus 4 by minus 3i is plus 12i, and then this gives me minus 12i, so the i's cancel, and then we have a plus 3i by a minus 3i, which is minus 9i squared, which is going to give me 16 plus 9, which is 25. So that's when you can use the conjugate roots, but this bit down the bottom, you can't. So a nice complex number of questions to start 2016.